Alright, so now we're going to start looking at using that Pythagorean theorem in a coordinate plane. And we've been looking at coordinate planes for a long time in school. So if you remember, let's take a step back and think about a coordinate plane. Coordinate plane is just, you've got your axis, you've got ordered pairs. So here is my y-axis, here's my x-axis. If I'm trying to plot points, which you're going to have to go to plot points to go to do this, you've got to remember, I've got to go left or right first, then up and down. Think of it as, I got to get to my stairs before I can climb my stairs. So this, if you remember, is called quadrant 1. And that is where everything is positive. So you have ordered pairs in the form of x, y. And in quadrant 1, everything is positive. You have a positive x and a positive y. This would be quadrant 2. In this one, I'm going left for my x value, so that's a negative x and a positive y. Quadrant 3, I'm still going left for my x value, so I have a negative x value, and because I'm going down, I have a negative y value. Then finally, quadrant 4, I go positive for x, because I went to the right, and I'm going to go down, which is negative, so I have a positive and negative. If you can keep that idea in your mind, plotting points should not be that bad. So, the very first example, it says we can use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. So the very first thing we want to do is, if you look over here at this reminder, kind of a helpful hint, it says to find distance between 2 points on a coordinate plane, graph the points and draw a right triangle with C as the hypotenuse. So if you're given that graph, plot your points and create that right triangle. Remember, Pythagorean theorem only works with the right triangle. So for example 1, we're going to graph the ordered pairs 3, 0, and 7, negative 5. So I'm going to start with 3, 0. So I'm going to start in my origin, and I'm going to go over 3, so 1, 2, 3. And because it's 0, I'm not going up any. So that would be my first ordered pair. I'm going to call that A. 7, negative 5. So I'm going to go over 7. So 3, 4, 5, and I'm going to have to run out my graph a little bit. So 5, 6, 7, and down 5. 1, 2, 3. So I'm going to have point B right there. So here is what I'm trying to find the distance of. I'm trying to find that length there. So now I'm going to make my right triangle so I can use that Pythagorean theorem. A right triangle could be drawn here, like that. So really what I'm trying to find, by finding the length of those 2 points, is I'm trying to find my hypotenuse. Now, on a coordinate plane, the benefit of a coordinate plane and drawing those right triangles is it gives you straight lines. So that means instead of trying to figure out how long each of those legs work, I can just count them. So that would be 1, 2, 3, 4, 5. So that leg has a length of 5. My other leg is 1, 2, 3, 4. So it has a length of 4. So I've got Pythagorean theorem. I'm going to plug 5 in for A, 4 in for B, and you can do those interchangeably. 25 plus 16 equals C squared. Because I'm solving for hypotenuse, I'm going to add, and I get 41 equals C squared. Remember, your very last step will be to take the square root. And my directions say to round to the nearest tenth. So when I type the square root of 41 in my calculator, I get 6.4. So the length between A and B would be 6.4 units. All right? So this one, I want you to pause it, and I want you to try it. So pause your video and try it. All right, so the first thing we want to do is graph ordered pairs. Because x starts out with a 0, that means I'm not going left or right. But I'm going down 6 because it's a negative. So 1, 2, 3, 4, 5, and then 6 would be there. 5 negative 1 means I'm going over 5 and down 1. So I want to find that distance there. Now, because you're on the coordinate plane, you've got several options for drawing your right triangle. You could draw it this way, or you could draw it this way. I'm going to use the one in red because I had to go off my graph a little bit, so I'm going to use the one in red. So once I get my right triangle drawn, I'm just going to count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So both of my legs have lengths of 5, so I'm going to try to find my hypotenuse.
Shavante Johnson, please come to the front office at this time. Your ride is waiting. Shavante Johnson.
So now I've got my 2 legs plugged in, trying to find my hypotenuse. So 25 plus 25, because that's 5 squared. Add those together. Take the square root, and I've got 7.1 in my calculator, once I rounded it. Okay, pause it here, and I want you to try this one. Okay, so I'm going to plot my points. 1, 3, negative 2, 4. Well, I have a very little triangle. So again, I'm trying to find that length there, so I'm going to draw my right triangle. Count my lengths, which are my legs. So I've got 1, and then 1, 2, 3. So instead of putting my formula, I've got that 1 plus 9 squared. 1 plus 9 is 10. So I'll take the square root. Then I get in my calculator 3.2 units, and you don't have to write the units. All right, so now we're going to look at what happens if I don't have that coordinate plane handy. If you're given 2 points and they want you to find the distance between them and you have no graph, the easiest thing to use is the distance formula. And I'm thinking what you're going to see is even if you do have that graph, you're going to like the distance formula. The only thing about the distance formula is it's not on your formula sheet for your milestone. But if you look at what this is explaining, the Pythagorean theorem and the distance formula are basically the same thing. Here's your distance formula here. So if you look at that formula, you've got the square root, and then what you're doing is you're taking both of your x values and subtracting them, squaring that, and then adding that to the difference of your y values squared. So if you look at example 1, or example 2 in this case, on the map, each unit represents 45 miles. West Point, New York is located at 1.52, and Annapolis, Maryland is located at negative 1.5, negative 1.5. What is the approximate distance between West Point and Annapolis? And then you've got this map over here that's showing you what that means. But because you're dealing with halves, fractions, so on and so forth, it's very difficult to count that. So here's where you want to rely on that distance formula. So my distance formula is I'm going to take my x's and subtract them, square that, and then add that to the difference of my y's squared. So what I would do in this case is I was looking at my ordered pairs. There's the first one. I would make sure I know this is my x value, this is my y value. That way when I plug them into my equation, I already am sure this is x, this is y. So I just need to substitute it in. So let's see, my other one was negative 1.5 and negative 1.5. So we've got an x and a y. With this formula, it doesn't matter which x you start with or which y you start with. Because you're subtracting them and squaring them, that part doesn't matter. So I'm going to take both of my x's, 1.5 and negative 1.5, and plug them in for my x's. With negatives, you have to be very careful because your formula is to subtract. So if you have a negative, you're going to have to do minus a negative. For example, this is what I mean. Minus negative 1.5. Now, some of you are going to want to go ahead and say that's plus, and that's fine, but be very, very careful doing that. Plus, then I'm going to put my y's in. All right, now, with your calculator, because we're back to using our graphing calculator as long as we can handle it, plugging this in is a one-stop shop. I'm able to plug this whole thing in my calculator. So in that calculator, you want to start out by opening up your square roots. Then you need your parentheses, then you need your squares, and so on and so forth. The biggest thing here is to make sure you're closing your parentheses. If you don't, it's going to give you an error. But if you've written it out, you're going to take this whole thing and type it in your calculator, exactly as you've written it. So when you do that, you should see 4.6. Now, that is not my final answer. Those two cities are more than 4.6 miles apart. If I go back up to my question, it says each unit represents 45 miles. So what I've solved for is that they're 4.6 units apart. Well, one unit is 45 miles. So I'm going to take my 4.6 units and multiply it by 45 miles. So when I do that, I get that they are about 207 miles apart. This would require us to go one step further. All right, next one. If you want to pause it and try it, you can go ahead and pause it and try it. Reed lives in Seattle, Washington. 1 unit on this map is 8/100 of a mile. So let me move this. And you can see that there. Find the approximate distance he drives between Broad Street at Denny Way, which is 0, -1, and Broad Street at Dexter Avenue, which is 4, 5. So I'm going to take both my points, so 0, -1, and 4, 5. And let's see, I'm going to label my x's and my y's. So x, y, x, y. Then I'm going to plug that into my distance formula. So x's first, y's second. All right, when I plug that into my calculator, I get 7.2. And remember, that's only 7.2 units. I haven't solved miles or anything like that yet. So 7.2 units, each unit is 8/100 of a mile, so I'm going to multiply. And I get that those two, he drives about 0.58 miles. And make sure to include your units from one to the other. Okay? Now I want you to pause it and try it. Alright, B says Cromwell Field is located at 2.5, 3.5, and Dedeaux Field at 1.5 and 4.5 on a map. If each map unit is 1/10 of a mile, about how far apart are the fields? So let's see, we've got 2.5 and 3.5, and 1.5 and 4.5. So we've got an X and a Y, X and a Y. So plug that into my formula. X is first, then my Y's. Then I'm going to type that onto my calculator, and that gives me 1.4 units. All right, so then I have to go a step further and say that each unit is 1/10 of a mile. So I'm going to take my 1.4 units times 0.1 miles, and I get a total of 0.114 miles. 0.14 miles apart. All right, last example. Use the distance formula to find the distance between x and y, round to the nearest 10 if necessary. So for this one, this is just use the distance formula, apply the distance formula, find your answer. So I don't have to go that extra step. So let's see, we've got x's, remember with the minus and negative, then I've got my y's. Type that in my little calculator and I get 8.2. Alright, once you are done with this, turn everything off, log it off, and this is your assignment. Page 367, number 1 through 8, all. When you finish, turn it in. If you don't finish it, it becomes homework.